Good afternoon, everyone, and welcome to our webinar on inventory optimization as an essential step in your S&OP process. The agenda we have foreseen is the following: introduction into Solventure and our mission on S&OP, and the way we see that inventory optimization is an essential part of S&OP. We will explain our methodology on how we see inventory optimization and the framework we use with our customers. Then we want to use multi-echelon production distribution networks, and we will use a simulation game to explain that. Next, we will review the results because they are sometimes counterintuitive, and multi-echelon is sometimes the next step for companies to grow further in S&OP maturity. Hopefully, we'll have time at the end to answer questions. First, a short introduction on Solventure. This presentation is coming from the S&OP side. This is one of our solutions. We also have two other business lines, Solventure Life and Solventure Academy. Life stands for Leading Indicator Forecasting, and is actually the leading indicator forecasting engine. We have developed a software that allows you to make a forecast that takes into account external macroeconomic factors. Over the last few months, we have built up a database of more than 1 million market indicators with data coming from Europe, the US, China, from sources such as the Federal Reserve and China Bureau of Statistics. What we do is on a tactical level. We analyze what the drivers are for the macroeconomic factors for certain sales in certain regions for a certain business line. And we then improve the prediction in terms of the forecasting. If you want to know more, you can find more information on the website. We also have the Solventure Academy, which gives you open trainings and in-company trainings. So the topic on S&OP we will be discussing today, you can do trainings on that in your company, and we also invite you to our open trainings in the Netherlands and Switzerland. Solventure Academy is based on developing the right supply chain knowledge in your company to ensure that you develop the right set of solutions. This session is hosted by S&OP. So let me try to introduce Solventure S&OP, who we are and how we work. I'll start with how we work. On the left slide here, you see a diagram that shows 4 components: process, tools, analytics, and people. At Solventure, we give advice on how to organize your S&OP process, and that means all of the dimensions of the S&OP process. We help companies in FMCG to define how they can do promotions planning, defining SKUs in different locations to see how they can optimize their inventory management and process. We help companies in the chemical sector to define the need to optimize their supply planning on certain thresholds and on certain reactors, and organize a board meeting which is linked to S&OP. We basically bring in-depth knowledge of the S&OP process to our customers in different industrial sectors. But we do more than that. You can also get process management consulting. In our projects, we also work with tooling. On the right side, you can see that Solventure is a unique channel partner of Arqiva. So, if you are looking for S&OP software or a planning software, we present the Arqiva solution, and in our projects, we always use the Arqiva solution to bring working solutions to our customers. We don't just give advice. We want results so we can work with deliverables of our purchases to have a good working S&OP solution. Analytics is a key component in all of the sub-steps of the S&OP process. With the analytical aspects, if you look at demand planning, you have sometimes something like statistical forecasting. Today we will talk about inventory optimization. Statistics can be used on models of monitoring inventory parameters. If you look at supply planning, you can use linear programming to optimize supply planning. All of these are highly analytical things, and when you combine these with a good process and a good working tool, this easily takes 30 to 50% out of that existing inventory. But this also works the other way. If you plug in a turbocharger in the wrong way, you will explode the motor. To make sure it doesn't explode, we make sure that our consultants also have very good analytical skills. and that they are trained for that. When they join a company, it is essential to make sure that also the analytical aspects of the S&OP are being matched. The following is of course people, because you can have the best processes, the best tools, and the most advanced analytics, but if people are not part of the solution, then they will simply not use it. And 6 months later, they will go back to their Excel files for their demand and production. So incorporating the people aspects in the blueprint process, but also in the way we give training to people, is essential in the Solventure approach. Don't forget, process, tools, analytics, and people. That's how we differentiate and how we combine our expertise. The different aspects of the S&OP process are shown here in the circle, but today we'll be focusing on inventory planning, plus a short word on segmentation. What we see is that a lot of companies still use the same approach for all customers and all locations. And that's a wrong approach because customers are not equal. They don't have an equal turnover, they don't bring equal margins, they don't have the same connection with the supplier and also the customer, but also the products are not equal. Some products will reflect the past, some are more strategic and will reflect the future, some are easy to produce and some are very complex to produce, so products aren't equal either. Segmentation is a kind of tactical and strategic decision that we do with our customers, supported by our module to make sure we define the front line. How we will define customer segments and what type of service we want to be delivered to which type of customer segment. For us, this is an ideal part of the S&OP process, or the ideal project to start with. Good S&OP management has to do with the product management portfolio. The challenge here is that we believe that some productions are overstated, which creates an excess of inventory of those products. It also means that some products are understated, and that of course creates service issues, which can affect your turnover. You don't want to be out of stock for a new product. Making sure that you tie into product management to get more accurate forecasts or follow-up is essential. The second element is that some companies are very good at introducing new products, but very bad at taking products out. If I'm in sales, it will lead to problems because if you take our products, typically you will lose revenue. So how do you solve that problem? The first message should be that if you can take our products without hurting your revenue, that will be really great. Because then if you're not moving stock, so we don't need to be earlier in the process. Then we also approach the module in Archiva, which helps you with that based on supply chain triangle. But I'll come back to that. Then demand planning, of course. Archiva as a tool provides statistical forecasts that need to be linked to a collaborative process, where we get input from salespeople about, for example, promotions, and from marketing people. Basically, you need input from different departments. Information from finance is needed to get financial insights, cost prices, etc. All of that is in a review supported by Archiva. Next, we have inventory planning. I'll come back to that. Supply planning works with different levels of detail and variations. On the one hand, it supports your master planning, but also your rough cut capacity planning. We do that in a bit more of a manual-driven way. We also have an optimizer available which can help optimize this. We also have webinars that cover each of these topics, and we also have vision papers for each of these topics. We can't go into detail now, but if you want to know more, please reach out to us. Of course, then we come to executive summary of S&OP, where basically you give your CEO an insight in the S&OP process and where you give an outlook on what will be going on. So, what will we sell, in which type of markets, for which type of products, what will be the revenue, what will be the margin, what will inventory come down to, what is the effect on the multi-echelon. All of this you will want to summarize in the executive S&OP. First of all, to create visibility, and second of all, to get your CEO on board. We live in difficult times, so for products, for example, coming from Turkey, you'll be able to analyze what will be the effects on the timeline of the inventory and on the working capital. Based on these scenarios, you'll want to make sure that everyone is aligned and is getting the right support. All of this will be delivered in the executive S&OP. I've written a book on the supply chain triangle. I won't go into too much detail right now, but basically we see that it's all about balancing the service, cost, and cash. If I'm in sales, then I'm service oriented. If I'm in production, then I'm cost oriented. And in many companies, supply chain carries the responsibility for the inventories, basically cash. Of course, if you then want to change service level or you want to change production, you have to take care of the service, cash, and cost. The S&OP process serves to improve the balance, as a balance in a triangle serves to optimize the turnover. We also have a vision paper on that, so if you want to know more, you can check it out on the website. If you want to make this process working, what is crucial? Aggregation, disaggregation, volume, and value. Let's start with aggregation and disaggregation. On the one hand, if you use S&OP, you want to show aggregate figures, but the devil is always in the details. So if you want to plan specific use of a specific machine. If you make forecasts for a product, for a specific customer in a specific region, it is important to see how powerful aggregation and disaggregation is to make this process work. Scenario management. The only truth about a forecast is that the forecast will be wrong. So what would be an optimistic and a pessimistic scenario? So that's when it's about individual products, you can be aware of the significance in the demand area that you need to consider. In volume and value, when we call it S&OP, but in fact, it's integrated business planning. If you run it into SAP nowadays, you won't be able to do it in volume and value. Instead of having financial planning and an operations and supply chain planning, you want to have one integrated business planning that goes in volumes and values in different currencies. An easy translation from volumes to values and a possibility to work with different currencies is crucial. And we are happy to be a part of Arqiva because these are basic strengths of the Arqiva tooling and the type of capability of each module of the Arqiva software. This is an overview of the Arqiva modules, but we won't go into detail because basically Arqiva supports all of the steps we have shown before. Arqiva also has connectors to the main S&OP systems, such as SAP, so that we can make life easy and take out the data to be flexible in your supply chain planning, and then get back the results you need. For instance, to do an operation follow-up of the interactions of your ERP system. These are some example customers. So Arqiva originally grew from the chemical industry. A lot of the expertise is from there, but you see that together with Solventure, Arqiva has grown with references into a broad range of sectors. And it varies from food-driven companies to companies such as Ferro Mogul, situated in the automotive industry, where in Europe we work for the automotive business, where they have a lot of SKUs, a big product complexity, sitting in different phases. So that's a good example of how we can support inventory optimization. If you'd like to hear about more references, again you can consult our webpage or ask us. But let's continue with inventory approach. So how do we approach inventory? Well, first of all, also when we do a webinar on inventory, we see a lot of interest in the reason because your inventory touches upon everything. Basically, the return on capital employed here on the left is composed of the EBIT, the profit, and the capital employed. The capital employed is basically composed of the fixed assets and the working capital. If you look at your EBIT or the profit side, you see that this is composed of your variable and your fixed costs. If you know where inventory management can have an impact, then clearly, if I can optimize my inventory, I can improve my service and at the same time reduce my inventory. So it always goes in both directions. Improve your service and you will at the same time reduce your inventory. Improving service will increase the top line. You will have less lost sales because they won't want to buy it from someone else. But apart from the gap between what you have available and what customers request is always the operational firefighting. So the customer calls and you don't have the products, then you will go to production and you will make a change that was not planned, what is not optimal. So basically, you will make an extra operational cost to close the gap. You will do an extra production or an extra shipment. And we've seen a lot of goods flying over the world in express shipments to basically close the gap, that the inventory was not available because of bad demand planning and bad parameters. Improving the inventory management will typically also improve your variable costs and both contribute to increasing the profits and at the same time you will reduce your inventory. So you will reduce working capital. So it's really helpful to touch upon your return on capital employed in a very direct sense. This is a clear reason why it's valuable to optimize inventory in companies. How do we do it? Well, if you want to improve your inventory, you want to know what it's about. Inventory is a relatively complex thing. It starts with realizing that there are different types of inventories and that there are different reasons why people hold inventory. That's summarized on the slides on this chart. On the top here we see the cycle stock. This is linked to the frequency in the production of ordering. So if I produce or order goods once every month, I will have them in inventory. If on average I produce them every week, that will create a cycle stock of half a week. So cycle stock is created by the production or the ordering frequency. Safety stock is there to absorb normal uncertainty on demand and supply. So if you do S&OP, typically it will be forecast driven. If you make a forecast, you know what the forecast will be wrong. The question is, how good is it or how bad is it? How big is the error? I will need to protect myself against that forecast error through the safety stock. That's on the demand side, but you can also put safety stock on the supply side. If I know that production is not very reliable, or if I need to import goods from Europe or the US to Brazil, and there's difficult customs, there's a lot of uncertainty on the delivery lead time. All of this should be incorporated in the safety stock. If you don't want to have stock ruptures, or if you don't want to have a loss in service and operational firefighting costs. The third layer is anticipation stock. It means I know that there will be a lot of imbalance between supply and demand. For instance, if I have a collective shutdown of a plant for 2 weeks in August and 2 weeks in July, then I know I'll have to mind that gap so I produce stock up front. If I have a major shutdown of a machine, then I know I'll need to anticipate and produce more stock in advance. If I go live with a new ERP system, there's a lot of uncertainty, and whether it will be able to deliver, companies usually keep extra stock either on the central or the decentral locations. These are examples of anticipation stock. Basically, the anticipation stock is stock in anticipation of a known event. I'll skip the strategic stock because strategic stock is there for strategic reasons. It can be that I expect a certain increase in price with a supplier, or that I say, well, typically in summer or winter, there's a summer or winter peak, and I need kind of a strategic stock to read to the market. These are typically uncertain events, and my inventory is probably hedging against the risk that has a strategic purpose. Strategic stock can be a very important driver for inventory. I see companies say, well, since January and now March, my inventory has gone up by 25%, but I can't explain why. If you don't know what is driving your inventory, then you will never be in control. First step is really understanding different drivers and being in control in realizing those different reasons to carry inventory. In process and in transit stock is when I have a lead time of 4 weeks to China by boat, then I know that the inventory is in transit stock. The process inventory is in process on the working floor, so that's also a part of your inventory. Related to S&OP and supply chain planning, well, the top two first talks really start with the calculations of the inventory parameters. What's optimal safety level? What's the ordering and production quantity? And basically all the inputs that you put in your inventory parameters. If you look at anticipation stock, that is the result of your supply planning. Your inventory parameters will be an input to your supply planning, and then in the supply planning, you really start adding capacity constraints. If I have a shutdown of 2 weeks, or I know I have a summer peak and I have limited capacity, I will rebuild. All of that is typically done in the supply planning part. Could be a rough cut model or a master planning model, typically in those types of modules. Your in process or in transit stock typically has to do with your process efficiency. So then maybe you want to implement inventory managing. You want to look at your warehouses to ensure that you create a good flow to reduce the lead time for the future. If it's about strategic stock, for us, strategic stock should be an S&OP discussion. It can be looked at from the purchasing side, the sales side, the supply side. Basically, you're looking at cash. You're building up strategic stock, and you might want to discuss this in the S&OP meeting as it is a tactical discussion that should be validated in the S&OP meeting. This type of inventory is very important, and these are types of inventories that have an effect on all the different steps of the S&OP process. And are modules that can be found in advanced planning software such as Archiva. This is our inventory framework. We use this with our customers, and it's kind of a checklist. We say, okay, if we set up an inventory management or an inventory optimization, that these are key to tackle. It starts with inventory policy. Then we talk about inventory parameters, inventory planning, and inventory monitoring. Let's start with inventory policy. Well, the first question is, do you want the same service level for all products? How will you segment? On the one hand, you do a more strategic product segmentation, because this is also the first step in the S&OP process in the Archiva model. It also allows a differentiation level for the different modules, target service levels according to ABC, XYZ classifications. What are my stock and make to order items? What will I put on stock and what won't I? That's also an inventory policy. The best stock is a stock you can avoid. If your customer is willing to wait 3 weeks for your product, it might be preferred not to have this product available in stock. The market conditions will define what is acceptable. Again, if in the inventory module you have some basic parameters and guidelines you can use to propose MTS or MTO stock. You can also do a validation process. You can say we have a basic proposal which needs to be validated by salespeople to ensure at least it's clear what are the rules and what are the exceptions to the rules. Central, decentral. If you keep stock on multiple echelons, then what are the stocks on the central or the decentral level? Is it only one level or on board levels? Is it also important to look at your reordering policy? So what are the products which are preferable forecast driven? Where you have a lot of push type, so DRP, MRP. Maybe you say the forecast is not reliable enough, or that the demand is so low that we don't want to make the effort to make or validate the forecast. It can be a reorder point or a max policy. All of these are design choices you need to make before you go to the next steps in the inventory framework. A lot of this is either currently not being done or has not been updated over the last years or the last 2 years. If they do it, they often do it themselves or in Excel, or it can be that you have a different approach with a different plan for different business lines. That is, it's not coordinated, not transparent, not well communicated to the sales team or the sales admin. These are important factors to address if you want to professionalize your inventory management. Next steps in the inventory framework is calculating your inventory parameters. These are important for the inventory layers. It starts with calculating the lot sizes, calculating optimal safety stocks, reorder points, and max and so on. This might depend also on the chosen order policy or on the MTS/MTO policy for all products. You know that you're going to calculate safety stock, so the inventory policy is needed to be able to calculate your inventory parameters. We're a big fan of using the statistical models here. It's a turbocharger, so not a best practice with a one-stop shop for all items. Then it's simply too much for some items and not enough for others. If you want to professional that, there are proven statistics available for that, available in a software like Archiva. We recommend to use something like that. At the same time, we are always very alert to make sure that the computer doesn't just take over. It remains a collaborative process, where a planner can make an override or where a certain person can make an override, because maybe there are certain contractual agreements with customers. If you have a contractual agreement that you have to keep at least 20 days of safety stock, then you need to keep 20 days of safety stock, even if the calculation would propose only 5. The calculation will give you a hint that you might need to review that contract because your 20 days is maybe simply too much, but in the short term, you want to be able to override what has been suggested by statistical methods and take that as a starting point for the next steps. We can do that on a single echelon level, but we can also do that on a multi-echelon level, as we will discuss on the next slides. I did a PhD on multi-echelon integration, which I finished in 2009. The result of the PhD is available in Archiva, and we will discuss how to tackle this in compared to single echelon optimization. Once you have your inventory parameters, we come to inventory planning. How do we see inventory planning? Well, if you look here, we typically calculate the safety stock. You can calculate this to a number of data based on historical data, and then you can define the balance of the safety stock. So your safety stock can go up or down in function of the forecast. Also here we typically add the required strategic stock. This strategic stock can either be on raw materials or finished products. It's important that you explicitly mention this as being strategic stock, because if from January to March your stock went up with 20%, you want to be able to explain to your CFO why the stock went up or why it went down. You want to be able to explain the difference, what the impact is of strategic stock, what will be the impact of anticipation. That's really the next step. If you get projected inventory, which is more or less the minimum based on the safety and the lot size, then you add the strategic stock, and that goes as an input to your capacity planning, your supply planning model. And in the supply planning model, you find the anticipation. So again, if you know that I have to shut down for 2 weeks, or if I know that the capacity always increases around the summer periods, then I need to pre-build stock to be able to accommodate this demand. For us, that's really part of a supply planning process, and the anticipation stock is then typically added as an output of that supply planning module. This time we say that our safety stock and our strategic stock is inputs to our supply planning, and the output of the supply planning module is the anticipation stock. You see projected inventory results, and you can then also show where inventories will be going up or down, and what will be the dollar or the euro impact. I will be able to visualize that and to include that in my S&OP discussions. Of course, all of this is planning, and we know that reality always turns out to be different. This can be because we sold more than expected, we used more or less than expected, or maybe stock had some quality issues and we had to quarantine it. Reality will always be different than the plan. If we know that, it's important to do close monitoring. This is the last and crucial step in the inventory framework. On the one hand, it's about reporting about the actual process targets, so that the target inventory is now the actual inventory. We will be able to see inventory turns in units, but also in dollars and euros. It's not only about how much is in stock, it's also about the balance, because maybe our target was a minimum of 30 days in inventory. It could be that my total inventory is completely in place, but that the underlying balance is completely wrong. This type of inventory reporting is typically done on an aggregated level. Maybe a product group in a certain region, or per plans for a certain product group. But it's not that on the aggregated level you give the actual expected target base. It could still be that along the lines, actual SKUs are in a safety stock, or you typically can be short of stock, or some SKUs are in balance, and for some SKUs you simply have overstock. So reporting and analyzing the underlying inventory balance is also crucial. If you can improve the inventory balance, it will help you get closer to your inventory targets. What else do we see in inventory monitoring? Another example is rebalancing across DCs. Another common inventory monitoring is slow-moving write-offs. What are the items that are slow-moving? Which are the ones that we are financially obliged to write off? What are the things that we say, these things are getting slow-moving? You might re-inject them to the product management discussion to see whether we still want to keep this product, whether we want to replace this product, and so on. Slow moving and write-offs will also be crucial in monitoring your product portfolio. All of these are starting points for our customers when they want to optimize their inventories. All of these functions are also supported by the Archiva inventory module. In the next step, I want to dig a bit deeper in the multi-echelon inventory optimization. What's it about, and what can it add to a basic type of inventory framework? For this, I use an example of a battery supply chain that is coming from research from MIT and was also used in my PhD. It's an example of battery manufacturers. What do we need? We need raw materials or components as an input. We typically buy this from external suppliers. Then I manufacture my batteries in bulk, and then I will package them into variants, maybe 3, 6, 9. So what do I need if I have a packing operation like this? I need both batteries, packing material, which I can buy from an outside source, and then I might store the packaged SKUs at a central location. Could be a plant warehouse. I might also store them at regional distribution centers, East, Central, and West in this case. This could be a US example. This example has multiple levels in the chain, or multiple echelons. So how do we link this back to the different types of inventory? Well, this is shown in this slide. I have steps in a supply chain. I have inventory of raw materials. I may have intermediates. I have finished products at a central location, which could be the plant DC. And I could have finished products in regional DCs. I also have different types of inventory. In each of these layers or echelons, I might have safety stock. I might have some pipeline stock, or I might have build-up or strategic stock. In multi-echelon inventory management, we ask, if these are the different levels of my inventory, then how do I optimize this? If I look at cycle stock, typically in a distribution environment, it's more easy to ship a pallet. If I go more upstream in the supply chain, it could be that the changeover costs are increasing. If this is the case, then my lot sizing is going up and my cycle stock will be going up. Even there you can ask the multi-echelon questions. If I can define what type of lot sizes I need in each of the different steps, I can also try to synchronize lot sizes. I can easily calculate that. Sometimes you can reduce the cycle stock by increasing the lot size. That is an example of the counterintuitive results of multi-echelon. You can reduce your inventory by increasing the lot size. If the downstream lot size would be 3 and the upstream lot size would be 5, then if you increase the 5 to 6, which is a multiple of downstream lot size of 3, you will see that you end up with a lower inventory. A lot of tools can be used to optimize your inventory policy step by step. That's certainly a good starting point if you have not started with calculations or advanced calculations of your parameters. The next step is to synchronize these calculations across different steps in the supply chain. That's what's multi-echelon all about. Now we will dig a little deeper in the safety stock. I typically use this simulation. Let's assume the following. We have a production in Asia and we have a European distribution center in Brussels, which is relatively central in Europe. I could have a central distribution center somewhere in the US, and I have 4 regional distribution centers. So if I would look at Europe, then maybe I still have regional distribution centers somewhere in the north, the west and the east. What else do we know? We see that the lead time for goods from Asia to Europe is 8 weeks, and that the time to replenish the regional DCs from the central DCs is 3 days. So this is a lot shorter. We have also given input on the lot sizes. In the European or the central DCs, it's 2 weeks. On average, every 2 weeks the EDC is being replenished from Asia and the lot size is 1, which means on average the RDCs are replenished once every week for this product. For the last year we have had 7 days of safety stock and there's pressure on the inventory. The CFO told us you need to reduce inventory by 30%. That means that out of 7 days I need to take 2 days. Instead of 7 days, I now have 5 days of safety stock left. The question we'll ask you is, if you have 5 days of safety stock, how do you want to elevate them over the EDC and the RDCs? I will give you an example. It could be that I say, I'll keep 2 days of safety stock at the central DC. This means that you have 3 days left to put out the RDCs. The alternative could be that I will keep 3 days at the EDC and then 2 days at the RDCs. We know that the target customer service level is 99% and that the customer gets the product from the RDCs. We will assume here that the customers are delivered from the regional DCs. In reality, you typically have a combined flow of the EDC and the RDC. This means that the EDC might have a double function, directly delivering to a part of Europe and also replenishing the regional DCs. Let's simplify that for a second and let's assume that for this case, the customers are delivered via the RDCs. The targeted customer level is 99%. So the question is, how many days of safety stock do you want to keep centrally? I will give you 10 seconds to think about it, and if you have a piece of paper and a pen, just write down a number. Now people typically don't calculate in their heads but try to use formulas, but just try to take a piece of paper and write it down for yourself. In the meantime, I will show you how I tackled it in my PhD research. When I first started doing this, the results are very counterintuitive. Later on, I was added to a group of supply chain professionals, and even those professionals did not agree with the results. When you first implemented it in companies, we had to show a simulation to show that the results of multi-echelon were true. That was going to work. Just to warn you, the results of multi-echelon are not always intuitive. As a result, implementing it might require a lot of change management. I will now show you a simulation we did for one of our customers a couple of years ago to prove him that it worked. Here you see the central DC. It's close to the production plant. The brown blocks you see here are the regional DCs based in Europe. Here you see the brown buildings that are relatively close to the blue factory. The others are further away and have a longer lead time. The big one was the US operations. That for them was really important, and I think that's here the goods came from Europe and had a lead time of more than 2 months to replenish that. We also use different colors, blue and yellow, and these represent different products. What we did to implement it was to simulate the flows. On the one hand, you see the stock going up and down. The regional DCs order from the central DCs, the flow is coming in. Sometimes you see a replenishment of a blue one, other times, for instance, a yellow one. All of that is defined by the lot size and the order, which is defined by the safety stock. Underline, we keep track of the inventory evolution. So this is a simulation of the reordering policy and actual inventories. You can also check the service levels. Sometimes it's very good, other times not so much. All of the research we did and the results ultimately came into the Archiva tool and have been extensively tested by this type of simulations. Now let's look at some of the results of our simulation game. First of all, these are the results of the same question we asked to different supply chain professionals. When I was doing my PhD, I played this game on a lot of supply chain fairs throughout Europe. We asked these questions to supply chain people, not even to marketing or sales people. On the left side, you can see their choices, and on the right side, you can see the simulation. Let's start on the left. What do we see? What I see is that there is clearly no consensus. If you ask this question to 10 people, you can get 10 different answers. There's only a limited number of people that have chosen the extreme. This is no stock at the central DC and push out all of the stock to the regional DC. If there will be a conclusion, then choosing 1, 2, 3, so spreading the inventory over the two levels and keeping a little bit of safety stock on the central level and keeping a little bit of safety stock on the decentral level is probably preferred over putting all of the stock in one of the echelons. If you look at the simulation on the right, you see that the service level goes up if you go more to the left. So if you keep less stock at the central DC and push out stock to the regional DC, then you see that the customer service is going up. You also see that the simulation results are not always exactly the same. This has to do with the simulated demand, so the demand is not the same in each of the simulation runs. That's why the results are not always exactly the same. It's clear to see that the better option is to push out the safety stock to the regional DCs. If you want to get rid of the variance, you can simulate over a longer horizon and then you get results shown here. So what do we see? If you have 5 units of safety stock, the only way to get a 99% service level to the final customer, and in case it's delivered to the customer by the regional DC, is to put the 5 days of safety stock in the regional DC. If you do that, then of course the central service level is lower, 78%, because you don't have any stock left. But as a final customer, I am not concerned by the service level of the EDC to the RDC. This is only an internal agreement between the EDC and the RDC. As a customer, I am concerned with the final service to me, which is the service level of the RDC. So this is a safety stock investment of 5 days. So for a fixed safety stock investment, strategies that put more safety stock in a market provide a better customer service. In general, I see that companies mostly keep safety stock on multiple echelons. We understand that if you want to deliver to your customers, you might not need a full 99% of service from the EDCs to the RDCs. So that means if you get 99% service level for the customer, we can also do it this way, keeping the 4 days of stock on the EDC and 3 days on the RDCs. That leads us to a total of 7 days. While Multi-Echelon tells us that instead of keeping 7 days of safety stock, we could actually lower this to 5 days. If I'm the CFO of the company, then I'm the happiest man alive in the world, because reducing the safety stock from 7 days to 5 days, that makes a huge difference. That's a 30% reduction without impacting our final customers. The customer still gets a 99% service level. The CFO will be very happy. If I'm the regional DC manager in Spain or in the Nordics, I will have a different view. I will say that there's a new concept, multi-echelon, but what does it mean? Well, centrally there will no longer be safety stock, so I get a lousy internal supplier. My service level goes down from 99% to 78%, and I, as a regional manager in Spain or in the Nordics, will have to pay for that. I will increase my safety stock from 3 days to 5 days, so that's an increase of 2 days on top of the 3 days. So that's a 66% increase. That's huge. Multi-echelon makes a lot of sense when you look at it from the supply chain perspective, but implementing it will be challenging from a change management perspective. There, if you look to implement multi-echelon, don't only look for a tool, but make sure that implementing is accompanied by the right skills to assist you in the change management. You should be able to explain why you come to this type of result. It is rather complex because it's highly analytical, so you also need an implementation partner with highly analytical skills. Certainly, all of that are things that we at Solventure aim to support our customers with. In general, we see that a lot of companies overstock upstream in their supply chain, and that if you really start rebalancing inventory on the different levels, it allows for 30% safety stock reductions. The first case that we did was with a client, and he summarized it like, multi-echelon inventory is a model which allows for multi-million-dollar savings. And this is proven practice. The simulation game is an example of a distribution environment, but you also apply the same to a production environment. So if you get back to the battery example and you apply the same logic, this is what I researched in my PSG, and what we have also implemented in practice with companies using Archiva. The single echelon situation here will be in the dark blue. You see that companies would typically have a safety stock on every level. They would have it on raw material and packaging, bulk, factory, finished production plan, at the plants or the central DC, and then at the regional DC. If you would apply the multi-echelon logic, then you will be able to shift all of that safety stock to the customer-centric location, the regional DC. Does it work? Yes, it works. Well, what's the impact? You could reduce your safety stock from 1.9 million to 0.34 million. And this is data taken from the case. So it's a 70% reduction of the safety stock. You'll need to accommodate that on the final level. You have to increase it from 0.2 to 0.34 million. That's an increase of 70%. We have simulated this. We applied the advanced simulation, and you see that the service level is 96%, which is above the 95% target. Now, why do we have a higher service level? Because mathematics are quite complex, and you typically make a conservative approximation. So we are still on the safe side. If you implement this, you will not go for the 70% reduction. For instance, from a production perspective, You look at what are really the key raw materials that I use in almost all of my products. You will make sure to keep safety stock here. Which are the bottlenecks? Then the theory of constraints say, never start at the bottleneck. Upstream of the bottleneck, you will still want to put safety stock. It's a new way of thinking. Instead of putting safety stock everywhere, you start from the baseline that you will want to put it on less echelons, which are the places that I really need safety stock. Where is that working capital really adding value? Because it helps me to lower the cost and to provide a better service. That's really making the most of your inventory in your supply chain. So that's what we have foreseen today. Normally, if you open your GoToMeeting, you have a question box where you should be able to post your questions. I'd be happy to take them and see if this helps. The first question here is on a simulation. I guess that it's about that you need a simulation to define the distribution. When you simulate, there are two options. Either you just look at demands and you use your historical demands. So you use your historical order book and you say you want to focus on that product at that location at that timing. You can really use your historical order book to run through the discrete event simulation. If you want to try that in practice, that might be something that makes sense. The alternative way is to work with samples from statistical distributions, which is more a conceptual validation. Both are possible. And the second question is on how to affect transportation cost of redistribution products between RDCs to increase customer service. That's a good question. I think there are two sides of the question. First of all, I think there is even a policy question. Before you start doing that, you need to define for which type of products you think that this makes sense. Typically for products with a very high value, it makes sense to do a shipment between DCs, because the transportation cost might be low compared to the inventory cost. If it's a very cheap product, you probably don't want extra transportation costs because that could destroy any margin you still had left. So taking that into account already in the policy and making sure that you define upfront where you will allow it and where not is an important first step. The second step is that typically when you do the shipments, then on the one hand, showing your alternatives, what are the lead distributions from a central location and what are they from at a central location could be a checklist for the location. And what are the extra costs involved? I think it could be a good thing to do in moderate inventory decisions. I see other questions here. So how do the transport costs can be taken into account into the simulation and the storage cost factor? Well, let's start with the supply chain cost factor. There is a result that you push out safety stock that is counterintuitive. Typically, people say, well, I don't want to sell stock to a regional DC where the forecast is not accurate. I understand that, but at the same time, if at the regional location the forecast is correct, then you have to have a good service. Then you already need safety stock. Once the safety stock is there, then it works as a magnet to attract other risks in the supply chain. That's how a multi-echelon works. But it is a fact that the risk at the regional location is higher than the risk at the central location. If you optimize your inventory, you can do it in pieces. But you don't want to do it in pieces, you want to do it in value. The decentral stock is more expensive compared to the central stock, and actually you want to do it with the inventory carrying cost. And the inventory carrying cost will reduce the risk of the inventory, and then you take a higher risk sensor at the decentral location than at the central location. If you look at the transport cost, then at the one hand, at the decentral location, you will work with the landed cost, so your transportation cost should be taken into account. If you decide to make a shipment yes or no, then your policy is really about rebalancing the inventory parameters. it doesn't affect the amount of goods that go from point A to point B over a longer period of time. It will not structurally affect the total transport cost of going from point A to B. Only maybe when you first install the evolution, you might need to ship more extra stock. If you build more stock somewhere, that might slow down production because you're temporarily replenishing the stock at this location. But this is only temporary. How do we forecast the demand of the customer in the simulation? Historical or some other method? The simulation is very flexible. You can use historical forecast, you can use statistical forecast that has been simulated by a statistical algorithm. Basically, you can try to use a simulation to really see what you're doing, because that's probably the best possible evaluation for this new inventory parameter. This might be a cause of concern for some of the people in your company. Some of these insights may be new and may cause some resistance. Try to make the simulation as close as possible to your current real-life situation, and that will help you to build trust. If you have done a simulation, we still advise you to start with a pilot, so don't immediately implement it for 100%, but maybe start with a subset of 20-30 aspects that prove that it works in real life. Once you have proven that it works in real life, then you can convince your company a lot faster. That's probably another important trick to do good change management. Time's up, we'll close here. Thank you for all your questions. And if you still have questions, please keep them coming. I hope this was interesting to you, and thank you very much.